Dear students, welcome back to our discussion on spreadsheet decision logics. In this short video, I'm going to talk about nesting if function. First, we'll see what is meant by nesting if functions. Sometimes you will have to use two or more if functions together in order to derive your expected output in your accounting model. Excel allows you to combine two or more if functions in order to achieve your expected or desired output from your accounting model. So when you use two or more if functions, when you combine two or more if functions together, it is called nesting if functions. Before looking at the structure of the nested if function, we will first again refresh your understanding about the basic if function. So basic if functions mainly include three components. There's a logical arguments, and there's a value if the argument is true, and there's a value if the argument is false. Unlike other functions like AND functions, OR functions, or NOT functions, those functions always give you two parameters, either true or false. Unlike other functions, if functions gives you flexibility to change its two parameters. For example, when it comes to AND functions and OR functions and NOT functions, all these functions gives its parameters as true or false, and you can't change these parameters. But if function also gives two parameters, true and false, but you have the flexibility to change these parameters. If you want, you can change them into numerical values, or you can change them into any labels you want, or you can replace these parameters with another function. So using this particular flexibility, we can combine two or more functions together, and you can extend your if functions with adding more and more functions to your original if functions. So when you add two or more if functions together, you are making nested if functions. We will look at the syntax for a nested if functions with two if functions. In these if functions, you can see you have first condition, and if the condition is satisfied, value for true, condition 1, and if the condition is false, if the condition is not satisfied, you are not giving the false value. Instead, you give a formula. Again, you say test for another condition. Accordingly, if the condition 1 is satisfied, value true for condition 1 is given. If not, you have to check another condition. This second condition is given through another if function. So if the condition 1 is not satisfied, go for the condition 2. Check the condition 2. Check the logical test 2. If the logical test 2 is satisfied, give the result value true for the condition 2. If the logical condition 2 is not satisfied, so what is the outcome? That is the value false for condition 2. So like this, you can combine two if functions, and you can have three parameters as the result. When it comes to three if syntax, in this if functions, you combine three if functions together. First, you write if functions with the condition 1, and if the condition 1 is satisfied, what is the outcomes? If the condition 1 is satisfied, or if the condition 1 is true, what is the outcome? If the condition 1 is not satisfied, you assign another logical test. You ask the formula to test condition 2. If the condition 2 is satisfied, you give the result, how the result should come. Value true for condition 2. If the condition 2 is not satisfied, again you give the formula to test another condition. Condition 3. If the condition 3 is satisfied, you expect this result to come. If the condition 3 is not satisfied, you give value for false for condition 3. If you are combining 4 syntax together, it will be keep adding like this. If condition 1 satisfied, and if the condition 1 is true, so what is the value true for condition 1? If not, you give another condition to check. If the condition 2 is satisfied, so what is the value true for condition 2? It may be label or it may be a value, numerical value. If the condition 2 is not satisfied, you give another logical test through another if functions. If the logical text or condition 3 is satisfied, so what is the value true for condition 3? You define it. If the condition 3 is not satisfied, again you assign another condition. You ask the formula to test or check whether condition 4 is satisfied. If the condition 4 is satisfied, what is the value for true condition 4? If the condition 4 is not satisfied, what is the value false for condition 4? Like this, you can keep adding lot of if functions together. When it comes to add lot of if functions again and again to these if functions, we have to be careful, because it is very likely that you would make errors, because lot of parentheses or brackets are opening, and you need to be carefully ensure all the brackets you open are closed, and you need to carefully develop these nested if functions. So we will now see how these if functions will work in accounting model. So we'll try a simple activity. In this activity, you are given names of the students and their informations. You are given names of 7 students and the score they obtained, they got for particular paper, and you need to give them a result. So grading system is given here. If the student score is greater than or equal to 50, you should give the result as pass. If the student's test score is less than 50, you should give them a result of fails. So we'll now see how we can develop. We can see how we can develop. Let's see how we can develop this accounting model with a basic accounting, with basic equation. So let's now see how we can achieve this objective with the simple if functions. Go to Excel. Let's delete this. select cell and paste. Okay, so we will put grade here. So this time we can, since we have only two parameters, since we have only two parameters, pass or fails, we can manage this with the single if function. So we can write if student score is greater than or equal 50, say pass, otherwise fail. So then okay, so we got the result. So Amal got 90, so above 50 pass, and Brian 72, above 50 pass, and Christopher 40 is below 50 is fail, and Dinesh 38 below 50 fail, and Easter above 50 86 pass, Farooq 60 above 50 pass, and Gihan 25 fail. Okay, so we'll try another scenario. So activity 2, this scenario, same set of data is given, and so this time there are three parameters. If the student test score is greater than or equal to 80, they are getting merit pass. The student's test score is greater than or equal to 50, they are getting pass as the result. Students who are getting test score of less than 50, they are getting fail result. So you asked to develop a model to work out this student result as merit pass, pass or fail. So this time you cannot rely on one if function. So this time you need to rely on two if functions. First write starting our first if functions and ask this logical test score should be greater than or equal 80. If true, say merit pass. If not, again we start if functions. If not, if this cell value is greater than or equal 50, say pass, otherwise say fail. Close the brackets. So we can then just copy this to other cells. So we'll check whether it's correct or wrong. So Amal got 90, above 80 is merit pass, and Brian got 72, below 80, so now merit pass, but above 50, so ordinary pass. Christopher 40, below 50 is fail. Dinesh below 50 fails. Easter above 80, so she got merit pass. Farooq 60, ordinary pass. Gihan 25 fails. So it works. So this time you can see here we used two if functions together. So when you use two or more if functions together, it is said you are nesting if function. So this altogether is a nested if function. There are two if functions, they are in this particular if functions. So according to this is called a nested if functions. We will now see another complicated scenario with another example. This time again same set of information, same students data set, but more grading systems. How many parameters? Grade A, grade B, grade C, grade F. So there are 4 parameters, so you need to have 3 if functions. 3 if functions. You need to use 3 if functions. Okay, we'll see. Again go to the data set. We start writing if functions. If score is greater than or equal, what is the range? Have a look. Greater than or equal 80. Greater than or equal 80, we say A pass. Otherwise if cell value greater than or equal 60, B pass. Otherwise again if cell value is greater than or equal 40, C pass. Otherwise D. So we open 3 if functions, so 3 brackets to close 3 if functions. So we'll have a look at the parameter, the grading system is correct. Yeah, less than 40 F grade. So I think we made a mistake. This is F. Okay. So we can just copy this. So result is Amal got 90, got A grade, Brian got 72, about 60, so B grade, Christopher 40, on the fence, so got C grade, Dinesh 38, below 40, F grade, Easter, she got 86, so above 80, A grade, Farooq got 60, on the fence 60, so got B grade, Gihan below the margin, 25 is less than 40, got F grade. That's it.